Arduinos are great for project work, but with only 2 kilobytes of RAM and 1 kilobyte of E2PROM, there's nowhere to store information. If you need images or want to log and retrieve data, you need to add an SD card. Let me show you how. Hi and welcome to Bytes and Bits. For simple control projects, microcontroller boards like the Arduino are ideal. But if you need to store or retrieve larger blocks of data, you simply can't fit it into small amounts of onboard storage. So maybe you're using an LCD screen and you want to display an image, maybe as a background for your control panel, or maybe your Arduino is doing some data logging and you want to store maybe some megabytes or gigabytes worth of information for later analysis. Either way round, you're going to need some sort of large-scale persistent storage, and SD cards are the ideal solution for this, and they're remarkably easy to connect to your Arduino project. Now in this project I'm going to be using an SPI based SD card, and mine comes built into my TFT screen that I've been using in some other projects, so I have a little SD card slot in here. But everything we're going to do will work just as well for a standalone SD card board. So let's get straight into it, get the board connected and then get some software running. Connecting up our SPI SD card is very much like any other SPI device. So this is our card reader here. And again, we have our normal SPI connections on that. So again, quite often your SD card reader will be working at 3.3 volt logic, so you will need to use some sort of level shifting to bring down the 5 volts from the Arduino to make it compatible with that. So I'm using a little level shifter IC in this circuit, or you could use a little voltage divider. But the level shifter does actually make it a bit more reliable, especially if you're connecting a number of devices. And in a later video I'll be showing you how we can combine our LCD screen, our touch screen and our SD card to make a little sort of data logging system. So what's happening here then is we have our level shifter, so we have a 3.3 volt feed down on this side, we have a 5 volt feed up on this side, so we're just powering both sides of our level shifter. I'm driving my SD card reader from the 3.3 volts because that's a 3.3 volt one. And again, you need to check with the datasheet on your particular card reader as to what voltage supply it needs. Then we're using our SPI signals, so these 3 SPI signals then coming from our Arduino. So pin 13 is our clock, so that feeds through our level shifter onto the serial clock. Pin number 12 is our MISO, so our master input slave output. So that should be coming into the Arduino from, all the way back down here, from the data out from our SD card. Then pin number 11 is our MOSI, so this is the master out slave in, so it's coming out of the Arduino through our level shifter and then on the data input on our SD card. And then the final connection we need then is a chip select signal. So I'm using pin 6 on mine. You can use whatever pin you want, to be honest. So I'm just using pin 6 because that matches up with when I add in my other SPI devices. So pin 6 coming out of the Arduino through the level shifter then and onto the chip select on my SD card. This particular little SD card symbol here has an extra connection, which is the card detect, and that's just a little switch that turns on and off to tell you when there is a little card plugged into the device, but I'm not going to use that in this. So we're just using our normal SPI connections, power and ground, and of course then we need, with our SPI connections, we need our chip select signal and just running that into any normal I/O port on the Uno. So looking at the actual devices I'm using on my circuit, I'm using an 8-channel bidirectional level shifter as shown on the screen there, and I'll put some links in the description down below so you can have a look at these on Amazon and so on. And this really then has two voltages. So the VA side is the low voltage 3.3 volt side, and VB is the 5 volt side. And you can see there we've got a common ground, and then this one has one other output, which is the output enable, this OE one, and that lets you then turn on and off the signal. So you just need to connect that up to the 3.3 volts. Then after that, the A1 and the B1, they then match as the two sides of the level shifted circuit. Then for my SD card reader, I'm using one that's built into my TFT LCD screen. And you can see there the connections on the left-hand side. So this one is being labelled with the actual SPI connections. So we have the SD CS is of course the chip select. Then I have the MOSI, that is the data input to the SD card. The MISO, so that's master input slave output, so that's the output from the SD card. And then of course the SCK, which is the clock for this one. Before we can use the SD card in our Arduino, we need to make sure it's in the right file system. So if we put it into our PC, you should then be able to, well, on a Windows machine, I right click on that and select properties. But you want to be able to go and see how that drive has been formatted. So for mine here, it's coming back reporting that I've got a USB drive in there, which is my SD card, and it is using the FAT32 file system. And that is exactly what we need. Now, if it's a brand new unformatted drive, or if you've been using it somewhere else, you'll need to reformat that. So on a Windows machine, I would simply come in here and I would then go to Format and then format that as my FAT32. But again, on whatever system you're using, you'll need to work out how you get that formatted into this file system. But once we've got that done, we should have a nice clean SD card now to use in our Arduino. So now that we have the card formatted and ready to use, we need to just make sure that we build up our circuit. So again, the circuit I've built up here is my full one with my LCD screen, touchscreen, and the SD card. So we have my SD card lead coming across and teaming up then with the common SPI connections, and of course its own individual chip select signal. One of the things with the SD card and the Arduino, if you are going to take it in or take it out, do make sure that you turn the power off. These are quite prone to corrupting your card if you insert or remove them while it's actually powered up. So turn your card off, insert your card, and then we can plug it back in, and we are ready to now program this and get some data onto it. So the software library that we're going to use is the built-in one from the Arduino IDE, which then they do have this SD library. Now, if you go to this web address, you'll be able to get to this reference page, and that tells you everything you need to know about how to use this class. So if we scroll down here, you'll see there's some information about the file systems it supports. One of the important things here is that it supports these 8.3 file names, and that really means that you have an 8-character file name, a full stop, and then a 3-character extension. Okay, so the file name can be anything up to 8 characters. It doesn't have to be 8 characters, and the file extension can be up to 3 characters. But do make sure that that is what you buy. If you try and make a file name which is longer than that, it just simply won't work, and it's sometimes hard to work out that you've just simply made a file name too long. There's nothing actually wrong with your code. The second important things are that it uses your SPI connection. So you'll need to make sure that you have your that set up, and we include the SPI library when we're building our Arduino sketch. We also have to make sure that we are aware that there's something called a working directory, which in effect is any time you specify a file name or directory file name, that is relative to the working directory, and that working directory is always the root of the SD card. So you can't actually move your working directory to one of the subdirectories. So every time you reference a file, you have to reference it from the root directory, and that becomes important when we start putting files inside folders and so on. But once you've got that idea of the 8.3 file names, the working directory always being the root, and it working on SPI, and very much the whole thing just works using a very simple set of methods. So we can see here that we have really two classes associated with this. One is the SD class itself, which lets us do sort of the more overall and directory based commands, where we can sort of set up the SD card using the begin, and then we can check for various things. We can make directories, remove files, and so on. And then when we want to actually open a file, we will use a file class. And then once we have that file class, that in effect connects that object to that particular file. And you can see we can then start reading the file and writing to the file and so on. So let's start by putting together a simple little sketch. So we'll start by including the two libraries that we need, so our SPI library and our SD card library. I'm then defining a few constants which will tell us which pins we're using. Again, you don't really have a choice here. The SPI pins are whatever they happen to be on your board. So I'm using an Arduino Uno. So my SPI clock is on pin 13, the master in slave out 12, and the master out slave in on pin 11. Pin number 10 on the Arduino is the default chip select for the SPI device, but because I'm eventually going to be using this with a number of different devices, I'm not using that for my SD card. So I'm defining a chip select pin on number 6 then for my SD card. Now, at the Arduino end, there's nothing really to see. Everything's happening obviously internally to the SD card. So we're going to use the serial monitor to allow us to send some messages up for debugging, so we can see exactly whether things have worked or not. So I'm starting off then in my setup function by initializing my serial channel to the correct speed. And again, you can see I'm matching that down on my serial monitor, down in this bottom right-hand corner here, to the same baud rate. Once we've gotten that, it's always a very good idea if you have any SPI devices to set their chip selects to the inactive state, which is high. So I'm setting, so you can see here, I'm taking the SD card chip select pin, setting it as an output and driving it high. And that basically disables that SPI device, so that as we are then setting up various other devices, we're not having one of them defaulting into an active state, so it's going to be sort of interfering with our other devices being set up. So it's just a good thing to do. Just set everything to inactive, and then we know that as we initialize each individual device, we're only talking to one device at a time. So down here is where we actually start to initiate it then. So as soon as we include this sd.h file, that will instantiate an object variable. So this is sd. And that is an instance of this SD class, which is the one which handles the overall running of the SD card. So we have a function here called, our method called begin, which will actually initialize the card and the connection with our Arduino sketch. Now, that takes one parameter. If you leave out that parameter, the SD card will use the default hardware chip select, which, as I said, on the Uno is pin number 10. And that's fine if you've only got one device. But we are here, of course, as I said, we are specifically telling it, I want you to use pin number 6 as the chip select for my SD card. So calling sd.begin with our chip select pin, that will try to initialize a connection with the SD card. So that function returns back a true or a false. True means that our SD card has been found and we're now connected to it, or false will tell us that something's gone wrong. So I'm just catching it here. So I'm calling my function. If that returns back a false, then we're simply going to output the SD card initialization failed, and we're just going to trap the code in this little while loop. Else we're going to say that the SD card is okay, and at that point we would go off then and do the other things. So to get this working, I'm going to first of all try this by unplugging my SD card, and we can then upload this sketch and see what happens. So we can see there that our Arduino has correctly identified then that the SD card isn't in the slot, or there's something happened with the SD card. So if I plug the SD card back in again and come back in here and reset it, we should find then that our SD card is detected. So we're now ready to go and start writing some files to that. So let me just paste in a block of code just here. Okay. So what we're going to do is we're going to create a text file, write some information to it, and then read it back in and send that contents back up to our serial channel. So we've already got our SD card initialized. So our SD object is now able to communicate with that. So we need to create an instance of a file. So we're just creating a new variable here. So it's a file variable. And we're creating that by calling the open method on the SD object. So we give it a file name. So remember, that's got to be in this 8.3 format. So up to 8 characters in the actual file name, full stop, then up to 3 characters in the extension. To be able to write to a file, we have to open it with the file write permission at the end of that. And that just simply then, what that does is if the file doesn't exist, it will then create a new file and open it up so we can write to it. If the file does exist, as we'll see in a little bit, that opens the file up for us to then append to the file. So what we're saying then is if that comes through okay, then we're going to just send back up to serial channel that we have created a new file. We're then going to send some information out to that file. And again, there's a number of ways in which we can do this. And this is very, very similar to the way that the serial channel works. So you'll see that there is a print. Well, if I come across to the class here, so we're looking at the file class, and you can see here we have our print line, our read, and our write. And those are very similar to the way in which our serial channel works. So you should be familiar with how these work. So we can just simply then say, okay, so we use my file instance. We are printing a line of text to that. So that will print, this is the first line of the file. It will, because I've used the println function, that will then append onto that a new line character. And at that point then we're just going to simply close the file. So remember, once you open a file, it will stay open in the writing state until we then close the file, and at that point the file is then completed. It is important that you do get into the habit of closing. So any files you open either for reading or for writing, once you've finished doing your work on them, it is important that you close those. If your program does end without you having properly closed the file, and that can cause a bit of corruption sometimes. I think the Arduino is quite good at making sure the files are closed, but just it is good practice to always close the files before you go off and do something different. So we've opened a new file, we've put some text inside it, we've closed it. We're then going to reopen the file this time, but this time in the read mode. So once you're in read mode, you cannot write to it, which makes pretty much good sense. So we're opening it up for writing. We're then going to simply loop through it. So we've got a little loop here, and we're using this method called available, and that basically says, so I've opened the file up, and that's telling me, are there still some characters available for me to read? So if there are, then I'm going to read in the next character. So I've created a little sort of character variable here. So we read in that character, and I'm then just writing it out to my serial channel. And once I've gone through and read all of the characters in the file, I can then just simply close the file, and that'll be the program finished. Now, this read method, it does return back actually a byte. So we can either read that byte as a character, or as we'll see in a second, we can actually read it as an integer byte. And again, that lets us then do much lower level file handling. So at the moment we're dealing with text files. So reading it back as a character is fine, and that will then make it easy for us to send that information back up to our serial channel. What we'll do in a second is we'll switch that across into byte mode, and we'll see we can actually read them as individual bytes. But let's just do this one to begin with and see if that's all working. So I'm going to send that down to the Arduino. And there we have the output from our serial terminal. So we can see that it's picked up the card, created the file, added the first line, and this last bit there is actually that line being read back out of the file. Now if I take that card and put it back into my PC, and bring this across here, we can see that we now have on my USB drive, you can see that we have now got this myfile.txt. And first thing to notice is that the file name has been capitalized, and that's what will happen with this filing system. The actual file names are case insensitive, so you can call them, as we did in the file itself, using lowercase, but that will relate to this file because it just simply assumes that everything is uppercase. And if I try and open that file in my notepad, let me just bring that across so you can see. And there we have, just confirm that we have created a text file which has got, this is the first line of the file, and it has got a new line character, as you can see, at the end of that line. So let me just close that down. So for now, I'm just going to delete that file and then just drop that back into my Arduino. So that's some basic file operations. But a couple of things to watch out for with this. So let's just reflash that Arduino again. So we know that we have a blank SD card. And we're getting back then our reporting of it creating that file. If I then just press the reset on the Arduino to get that code to run a second time, what we'll find, and a third time, and so on, what we'll find is that this block of code here, so this return here, that is the actual contents of the file. And you can see that we are gradually building up that line repeated over and over again. And if you think about it, what's happening is we're running the code, we're creating a file here, and we're opening that file in file write mode. And again, the logic here is that if that file does not exist, we open a brand new file. But if that file does exist, we will open it in write mode, and our write cursor will be at the end of the file. So in other words, if we then start writing stuff to it, we will simply be appending that onto the end of the existing file. And that's exactly, of course, what's happening here. And each time we reopen that file, we then append a new line, which is what we've seen on this side over here. So let's get around that then. And what we will do is when our code first runs, we're going to assume that this is going to be some sort of data file that we're creating, and that we want to make sure that this is the brand new data. So we're going to start off by checking to see if that file does exist. And if it does exist, we're going to delete it so that when we come to this piece of code, we will always be writing into a brand new clean file. So I've just dropped in some code. And basically what we're saying here is we're using, again, this SD object is the main control for SD card. So we're saying using its exist method, and then we're just giving it a file name. So if this file exists, then we're going to use the remove method to delete it. And at that point, we could then go off. And at this point, when we try to open that file, of course, the file doesn't exist anymore. So we get a brand new clean file. So let me just see if that works okay. So let's just make sure we save that and write that down to the Arduino. And there we go. Okay, let me just clear that output there. So if I press the reset button, we will get our code and we get one line in our file. Press it again, and we get one line in our file. So now we have a brand new clean file being generated each time we run through our code. So the last thing I want to have a look at with you is the use of folders for storing our files. So I've added a bit of extra code into our file handling sketch. So what we're doing is we're starting off as normal and getting the SD card up and running. But now what we're going to do is we're going to create a folder called data into which we're going to be putting our results. So our code has to first of all check if that folder already exists. So again, we're using our SD object, the exists method, and then we're specifying a folder name. Now, all file operations on our SD card have to be referenced from the root folder. Remember that idea of our working directory is always our root directory. So any file names you give and any folder names you give must be referenced to that root directory. So I have put in here /data. So that preceding slash is sort of implied because we always will be in the root directory. But I always tend to put that in just so I know that I am referencing this from the root. So that's just personal preference. You don't actually need that in there. So I'm saying, is there a folder in the root directory called data? If there isn't, then we need to make that directory. So we have a make directory, so mkdir method on the SD object, which lets us make that directory. So when we pop out of this line here, we will know that there is a folder called data in that root directory. Now, as we go through, we'll see that there are different ways in which we can manage our files. So I'm just pretending here that this sketch is going to create some data for some sort of experiment or whatever that we're running. And as opposed to previously where we just simply deleted the previous data and then created new data, what we're going to do here is keep all of the old ones live on our SD card so that we are building up a series of data runs, and we're going to put each of the blocks of data, so each of these myfile.txt files will go into its own folder, and that's all we're doing here then. And we can do the same process either with folders or with files, but the real idea is that we are generating a number. We have got a base name for our folders, so we're going to be in effect generating folders called /data/run1. Then the next time we run this code, it'll generate a folder called /data/run2, and so on. So we have a little counter. We're using this, again, be careful with the way in which you put or concatenate strings together. So it's best to create a string variable which has your base file name, and then we can concatenate easily against that. If you just try to use that pure string in this area here, you can sometimes get odd things happening. But anyway, so we're doing a little while loop here. So we're checking to see if a folder exists with the name of our base folder followed by this counter value. So again, as I said, that will go /data/run1, /data/run2, and so on. So as soon as we find a folder name that doesn't exist, we're going to log that folder name. We're going to report that back up to our serial channel so we can see what's going on there. And then we're going to make that folder. So at this point, we will have a folder which is /data/run and then whatever run this is. As we're going forwards, you can see that every time we now reference our file, we have to put our folder name in front of it. And again, those are all referenced to that root directory. So between our folder name and our file name, we do have to put in that sort of trailing slash. So all I'm doing here is, before we go off and start using that, I'm just adding a new trailing slash onto that string for run folder. And then after that, everything else is as before, just with this referencing the folder in front of my file name. So this should let us then run this code a number of times, and we will build up a log of all the data that was created on each of the individual runs. So let's upload that into the Arduino. And there we have our runs starting. And again, I've obviously been doing a little bit of testing on here, but if I now keep pressing my reset button, you can see that each time I do that, our card runs again, and we create then new folders for each of the individual data runs. Okay. So if I then put that card back into my PC, so there we have our drive open, and you can see we have our data folder. Inside that we have a folder for each of our runs. And if I look at my final run then, we have our myfile.txt in there. And if I open that, again we can see that that one there was created on run number 7. So that pretty much covers how we need to set up our SD card, and then some basic file operations and folder management. So do make sure you check out the project page on my website, and I'll put a link in the description down below, together with some links to the various bits of equipment that I'm using in this particular project. Going on from this then, I'll be doing some more work with my system and the TFT screen. Partly that will be in better handling of your files, so we'll have a look at how we can both generate CSV files, in other words some actual spreadsheet files from our Arduino. So if we are taking sort of experimental results and so on, we can log things like time, readings and so on, all as lines in a spreadsheet, which can then be read straight into our Excel on our PC. How we can both then create those on our Arduino, and how we can then read those files back in on Arduino and perhaps display those values as some data display on our TFT screen. I'll also be having a look at how we can use our SD card then to store some images which we can display on our TFT screen. So again, those are coming on some subsequent videos after this one. So if you are interested in that end of things, do make sure you subscribe to the channel so you don't miss any of the videos, and do turn your notification bell on. And hopefully then I will see you soon in another video. So bye for now. For more games programming, electronics projects and retro gaming, please make sure you like this video, subscribe to my YouTube channel and visit my website.